Video session. So in this video I'm going to deal with the topic from chemical bonding, and in that one the basic model of chemical bonding, it's ionic bond. Okay, so before that, why do few elements or few atoms or few ions, why do they bond? The reason, they want to become stable, right? They want their outermost orbital to be completely filled. They want the outermost orbital to have octet configuration ns2 np6, right? As you all know, if the outermost orbital is completely filled, they are stable. They can be inactive. They need not be too active to lose or gain, right? That's what 8th group elements, right? All the 8th group elements are 0 group elements, inert gases, noble gases. They are stable. Right. So the remaining group elements like 1, 2, 3, 4, 5, 6, 7, they'll be too active, right? Either to lose electrons or gain electrons to get stability, like 0 group elements, inert gases, noble gases. Right. So in this process of losing and gaining electrons, in the process of getting stability, there are many chemical activities involved, right, to make the process of stability. Right, the processes: ionic bond, covalent bond, coordinate covalent bond, polar covalent bond, many. Right, in that one, the basic model, ionic bond. Right, the bond formed by complete transfer of electron from one atom to another atom. Right, the bond formed between two. Right, it may be two ions or it may be two atoms. Right, but if the bond is formed by complete transfer, means it is not going to use it back. You take it, and it is going to take that. It is going to lose it, it is going to gain it. Right, such a type of bond, the bond formed because of complete transfer of electrons, is called ionic bonds. But for the atoms to come together, what is needed? Right, oppositely charged. Right, so cations are positively charged, anions are negatively charged. Alright, so cation and anion come close because of the electrostatic force of attraction, or the electrostatic force of attraction holds both cation and anion together. Right, such a type of bonding is called ionic bond. Just let me recall that one. So the electrostatic force of attraction that keeps anion and cation together to form a newly neutral compound. That's what I said. Cation positive charge, anion negatively charged, right? But when they combine, they become neutral, right? Such a type of bonding is known as ionic bond. Of course, we can also call it as electrovalent bond. Why? Because valence and electrons are involved in this bonding. Okay, that's what. So to make you better understand, we are coming with an example of sodium, right, or disodium monooxide. Disodium monooxide. Mono means single, di means two. Means two sodium atoms are combining with one oxygen atom to form disodium monooxide. That's what he says. Two sodium atoms combine together to form with oxygen, right, to form disodium single oxygen, dimonooxide. Right, so what? But please remember, after bonding, after the formation of dimonooxide, both sodium will become stable like the nearby unit. Right, oxygen will also become stable like the nearby unit. But you have to remember, sodium atomic number is 11 and the nearby unit to it is neon. Fine, neon is of 10 atomic number. Oxygen, its atomic number is 8 and its nearby unit is nothing but neon. But sodium atomic number is 8. It requires 2 more electrons to reach neon. Whereas sodium is atomic number 11. It has to lose 1 electron to reach the 10 neon. That's the game. One wants to lose, one wants to gain. There itself the concept is. So there the concept lies, the formation of cation and formation of anion. So here, cation formation. So the one which is losing electrons, the one which is losing electron is becoming cation, the positively charged particle, which are towards the right side of the periodic table, 1a, especially the 1a, they are highly reactive. Why? Because their valence is only 1. right? Their outermost orbital is having only one electron, that is, valence electrons are only one. It like to get rid of that. Not only sodium, all the elements of 1A group element, they like to lose one electron and become stable like the nearby units. So that's what, let me explain you. Sodium. So that's what the formation of sodium. Atomic number of sodium, as you all know, it's nothing but 11. Atomic number 11 means 11 protons. Here in this one, 11 electrons also. Right, now electronic configuration, I like to fill it out those 11 electrons in the orbits. In the first orbit, I like to place 2, as we all know. In the first orbit is nothing but K. We can accommodate 2 in that. Right. In the second orbit, KL, I like to accommodate totally 2 plus 6. 2 in the P, 2 in the S and P in the 6, totally 8. Means in the L orbit, the second orbit, it is completely filled. Why? Because 8. Now in the third orbit, K, L and M is having only 1 electron. Right. If you go for the stability like so and so, 2 are there in the first orbit, 8 are there in the second orbit and only 1 are there in the third orbit. Right. But please remember, when we are saying 2, 8, means here we are having octet configuration. Means before to sodium, right, there is someone who is inert. That is nothing but neon. Neon means 10. Right. Second orbit is completely filled. That's what inert gas electronic configuration, neon 3s1. By this, what we can say, till second orbit it is completely filled. That's why we have written neon. And the third orbit, there is only 1 electron present there. Right, so there is only 1 electron. Means in the M orbit only 1. Right, in the last orbit only 1. Last orbit means valence electrons. The electrons present in the outermost orbit called as valence electrons. So for sodium, there is only 1 valence electron. So you know, to become stability, right, outermost should have 8. Right, but how many sodium has? Only 1. To become 8, it requires 7 more, which is very tough. Right? It can't get those many. Maximum only 4 we can get. You have to remember that. So 7 it can't gain. So it gets rid of that only 1. Means if you lose that 1, the orbit which is at the back, now we are in the third orbit, right? If you lose that, we will be left over with the second orbit. It will be having 8 electrons, which is behaving like neon. That's the concept. That is the plan. So forget about that. Now, so charge. What is the charge of the sodium atom? Right? 11 protons and 11 electrons. 11 protons and 11 electrons, equal number. Right? If it is equal number, the charge is neutral. Right? In the same way, sodium atom, the symbol is Na. If you like to draw the Lewis dot picture, it is nothing but we are going like this. Means all the electrons, the protons and inertial electrons are represented by the symbol, right? That is Na, which one call it as kernel of the formula. And the outermost electron is represented with a dot or a cross. This is the Lewis dot picture of sodium. Okay, so as outermost orbital is not completely filled, it tries to lose, to get stability like nearby unit. Who is nearby unit? The neon is the nearby unit. To get the stability like neon, right, it likes to lose 1 electron and behave like 2, 8. Right, that's what he says. Lose 1 electron, right, or we can say it as lost 1 electron to get stability. It loses or it will lost that. So if it loses 1 electron, 2, 8, 1, so how many electrons will be there? It will be left over with 2, 8 only. Right, well, what happened? The last electron is last. Right, it has lost that electron. So electronic configuration will be getting like 1s2, 2s2, 2p6. Why? Because the last electron from the M orbit, it has lost it. Right, but please remember, number of protons remains the same. Therefore, its atomic number is always the 11. Right, but the number of now, as it has lost the outermost electron in the outermost orbit, it is behaving like something like saying 1s2, or it is behaving like a neon itself. Neon. Right. So if you remove the 1 electron, how many valence electrons there? Which is the last orbit now? If this is K and this is L, the last orbit is L, and it is having 8. So valence electrons are 8. Okay, now if you check it out, right, how many electrons are there? Totally 10. How many protons are there? 11. Are they both equal? No. If they are equal, it is atom. If they are not equal, it's an ion. What kind of ion? Is it positively charged, negatively charged? Depends upon which is more. Right. Here shall I say protons are more? Why? Because it is one more. Therefore, it is not an atom or it is not a neutral. It's nothing but positively charged. It's nothing but positive charge. Right, and it's no more an atom or it's an ion, positively charged ion. Okay, and what's the symbol of that? What the symbol of that? The same sodium, right? The same sodium. Now, see here, how many valence electrons are there in that? Right, 8. If you want, you can go with 8, but it's not, right? The symbol we can take out, which is more? Protons are more. You keep 1. How many more protons? 1 proton. So we can call it as sodium unipositive ion. How did you get that? By losing 1 electron to get to the octet configuration, sodium has become sodium cation. So let me represent with the diagramical representation. Alright, here the logic stays different. Logic, as we are talking about formation of disodium monoxide. So sodium I have discussed, but I am talking about two sodiums. That is what here. So 2 sodium atoms. So right here I have discussed about only 1. Similarly the second one. So we are talking about 2. So 2 sodium atoms. Right. So here 2 sodium plus ions. How many electrons? First sodium atom is losing 1 electron and the second sodium atom is also losing 1 electron. So totally in this compound, disodium monoxide, how many electrons are lost? 2 electrons are lost here. Okay, so that's what 2Na is nothing but neutral atom. It's nothing but cation and 2 electrons are lost. So see here, 2 sodium atoms lose 2 electrons and form 2Na plus. If it is only 1 sodium atom, Na plus. As we are taking 2 sodium atoms, 2Na plus. So in the compound of disodium monoxide, cation preparation is done. Who is ready now? 2Na plus is ready. It is waiting for the anion. Right, which is the anion? It's nothing but the chlorine. Says Cl minus. How the process going on? Yeah, till now we are discussing about the formation of cation. Now it's the turn to discuss about the formation of anion. So in the disodium monoxide, right, what we are discussing? The anion. Anion is nothing but the oxygen. Anion is nothing but the oxygen, right? How it is going on? Why it is planning to become inert, right? Why it is not inert? Which is the nearby inert? We are going to discuss regarding that one. So now you take sodium, oxygen, right? What is the atomic number of oxygen? It's nothing but 8. Fine, means 8 protons are there. Fine, right? How many number of electrons are present in the oxygen atom? Means 8. Right. So what is the electronic configuration? If you place those 8 electrons, if you distribute it, right, the arrangement, the distribution of the electrons in the respective orbitals, but we have to fill according to the energy level. First orbit should be filled first, later on the next energy level, later on the next energy level. Likewise, we are filling the first one, 1s2, 2 electrons accommodated. Later on 2s2, 2p4. So why? Because, right, it is filled with, we have arranged all the H's. Right. If you go for the inert gas electronic configuration, likewise, before getting into the second orbit, we are filling the first orbit. Right. But please remember, here 4 plus 2 means 6. What is the octet configuration? NS2, NP6. But here how many we have? 4. Means it is not completely filled. Right. So which is already filled till now is nothing but the first orbit. Okay. Right. So if we are filled with the first orbit and then we are entering into the second orbit. So till where we have completed? First orbit. Means we have completed till helium. That's what he said. First orbit completed means we are done till helium. Right. Helium, then comes the second orbit. Fine. Now in the last orbit, which is this is K and this is L, how many electrons are present? 6. Therefore the valence electrons are 6. Fine. Now, atomic number is 8, means 8 protons. How many number of electrons? 8 electrons, equal number. Therefore, I can call it as neutral. Fine. But the simple fact, if we asked to draw the Lewis dot picture, oxygen, right? How many valence electrons? 6, right? 1, 2, 3, 4, again 5, and again 6. See here, now we are able to figure it out. This electron needs to be paired. This electron needs to be paired. Why? Because around we are having valence electron, we should have 8. Right? Means oxygen, which is having 8 electrons, whose outermost orbital is not completely filled, is not stable. It's active. It too want to become stable like the nearby units. So atomic number is 8. Who is nearby units? 10 neon. So oxygen is in search of 2 more electrons. It is in search of someone who can give 2 electrons. It is ready to gain. Right? So please remember, oxygen is towards the left side of the periodic table. Are you able to? Towards, I think 7, 6, I think it's 6th, right? Yeah, it's 6th group, 6A group, right? Its valency is 2 and valence electrons are 6. You will know that. So now it is in search of 2 electrons. So it will gain those 2 electrons. But please remember, outermost orbit is not completely filled. It is in search of that and it will get it. From where? You know, it's from the sodium which we have just now discussed. Now, if you get the 2 electrons, it gets accommodated in the p orbital. Now it will become, helium is already filled and it is 2s2, 2p6. How did it become 6? 2 electrons are gained from the sodium. Now, so ns2, np6, totally 2 plus 6. Now, it is close by 2 neon. Right? Means oxygen, after acquiring 2 electrons, it will behave like neon, which is already an inert. So if you think about how many electrons are there in the outermost? If you check it out, it's nothing but 8 electrons. Therefore, valence electrons are 8. Okay. Now, is it a neutral or positive charge or negative charge? Now, you please think on. Atomic number is still 8. Right. How many protons it has? 8. How many electrons it has? It's 10. So, electrons are more. Right. So, how many more? 2 more. 2 more. Therefore, it is not going to be an atom, it is going to be an ion. Negatively charged ion. Why? Because electrons are of negative charge. Therefore, negative, right? But how many negative? 2 electrons are therefore di-negative cation. Why? Because negatively charged particles are cations. Right. Now, if you go for the electronic configuration, it's nothing but 1s2. Right, 2s2, 2p6. Right, now what's the symbol? Oxygen. But who are more? Electrons are more. How many are more? 2 are more. Therefore, we call it as 2 minus. Right, so oxygen atom has changed into oxygen 2 minus ion. Ion means negatively charged. Therefore, it's anion. So, we are done the process of formation of oxygen. Right, oxygen di-ion, which is nothing but negatively charged. Fine. Now cool. Now we are ready with the cation, which is nothing but 2Na plus, and we are ready with the anion O2 minus. What happens? Please remember, they are of oppositely charged. Sodium plus ion, which is a cation, is a positively charged. Oxygen 2 minus is nothing but a negatively charged. The opposite charges attract each other. Fine. Right? So now you have to remember, we took 2 sodiums. Right? Each sodium can donate only 1. So now 2 sodium atoms will donate 1 each to oxygen. So oxygen is getting 2, but these 2 are donated by 1 from the first sodium, 1 from the second sodium. So 2 sodiums are giving 1 electron each to oxygen. That is what you have to remember. That's what 2 sodium atoms transfer 1 electron each to 1 oxygen atom to form 2Na plus. The sodium is nothing but 2Na plus and oxygen nothing but O2 minus. This is positive charge and this is negative charge. This one, sodium is getting the inert gas electronic configuration of nearby inert, which is nothing but neon, and oxygen is also getting the inert by nearby inert gas electron or inert gas, which is nothing but the neon. Alright, that's what. Sodium gets electronic configuration neon and oxygen also. Now the reaction. Alright, when they come close, 2 Na plus, which is in the gaseous state, will combine with O2 minus, which is also in the gaseous state. This is positively charged, negatively charged, cation and anion, they combine to form a neutral. What's this? Disodium monoxide. Right? This is how the preparation of disodium monoxide is formed with the help of our favorite ionic bond. So here, complete transfer of electrons from sodium to oxygen. So it's an ion. In this channel, I have been placing both math and science videos.